with Alec. Alec, let me get your thing up.
Okay.
Before we jump in, Alec,
Yep.
excuse me for interrupting. One more thing that's not up there. I just want to remind everyone that we have a workshop Wednesday, tomorrow. We'll have the rebuttal workshop for everyone that's had the last less than 2 years. Our guest speakers or presenters are going to be Tony Festa, Matt Paparo, and maybe Frankie Paparella, although it's open for everyone. So it's going to be more active. It's going to be more interactive, and everyone's welcome to join, participate. And tomorrow it'll be a lunch and learn if you guys are here in the office. If not, we'll send an invite shortly after this meeting.
Great. Okay, so for my 2 minutes, I'll be talking about the James Webb Space Telescope. I chose 4 images to show you guys. We go into kind of some deeper detail that I was looking at. So for this one, this is the first image that NASA released to us about 2 weeks ago or a week and a half ago. So there's a lot in this image. There's thousands of galaxies, thousands of stars that we're looking at. I'm going to pinpoint one of them. So you can see 2 very bright stars or galaxies. One has that spiny or the spikes, which is from the telescope. So that's actually a star in the Milky Way, in our galaxy. The one I'm going to be focusing is the one a little below it to the right. Right where Ryan's cursor is. So that is 4.6 billion light years away. It is galaxy cluster SMACS 0723. I chose this one to kind of talk about just because it's really interesting. So you can see around it, you can see kind of a warp in the stars. It's a gravitational lensing effect. So you can see those stars that look like kind of those warped straight lines. That is just a star that's being warped by gravitational lensing effects. So it's just very interesting to see kind of in real time, or I guess in a picture, kind of seeing those stars being warped. If you want to go to the next picture, this is my favorite. So this is Stephan's Quintet, which is the largest photo of the released photos by NASA. It is 150 million pixels across 1,000 separate image files. What's really cool about this, you can see on the right, it's kind of stitched. All the 1,000 files are stitched together. So you can actually zoom in. There's obviously 150 million pixels, so you can zoom in as deep as you want. Obviously not in this presentation, but if you look it up and I can send out a link, you can zoom in really as deep as you like. It's very interesting. So the 3 galaxies on the right side are 300 million light years away, and the one on the left is 40 million light years away, so a bit closer, so pretty far. And what's really interesting about this photo is, so it's actually the same photo. One is using near infrared and one is using mid infrared. I believe the left is the near and the right is the mid. So focusing on the top galaxy, it's a cluster of galaxies, the top one. It's actually a supermassive black hole, and you can see it clear on the right side, the mid infrared sensor. So you can see it's a supermassive black hole, 24 million times the mass of our sun. It emits 40 billion times the amount of light of our sun. So yeah, that's pretty crazy. So that's a little about this picture. If you want to go to the next one. So this is Karina Nebula. This one's actually pretty close, 7,500 light years away. So a lot closer than the millions and billions of light years away. The image itself is 16 light years wide. So just to give you kind of an idea of how large this image is. So 16 light years wide, 7,500 light years away. So what you're seeing is gas. So it's kind of like a wall of gas. And what's interesting is that you can see through the gas and you can actually see stars behind it. So you can see stars that are in our galaxy with the kind of 6-star spiky thing. And you can see, galaxies all around the universe. If you go to the next one. So this one is really cool, and this is called the Southern Ring Nebula. So it's actually a dying star. It's been shedding its outer layers over time. It's only 2,000 light years away, so it is pretty close to us. So what's cool about this is you can actually see for the first time. So in Hubble, we saw the same picture. Obviously, Hubble does not use infrared sensors, so it's kind of hard to see through gases. That's the whole thing with red infrared sensor. You can see through gases. So you can see the actual white dwarf star that will become a white dwarf. It's not actually a white dwarf yet. So it's becoming a white dwarf, which is essentially a dead star. And you can see the gases that it's emitting out, which is causing that beautiful nebula. And that's really all the images I want to show you. There's a lot of images online, so I would definitely recommend looking at NASA's website. They have hundreds of images, and they're still releasing them every day. So I'm really excited to see kind of more images and learn more about the black holes and all that. So thank you for
Wow.
listening.